Hey folks, how's it going? Today we're 3 months into hacking on Jank's IR, custom IR, and we're gonna do a little more of that. We're so close to being ready to merge this custom IR into main, and then use it to do some fun optimization work. But there's a little bit we got to do. There's some more we got to do. Let's take a look at what we're going to be doing. So I think I want to do one of these, and I want to do one of these. I want to do one of those. Yeah. There's a little bit we want to change. So our IR on its own is fine. This would totally work. Like this is a particular case where it's something I want to change today. It would work on its own if we were lowering it to LLVM IR, or if we were interpreting it on a VM or something like that. But when we are generating C++ from it, it's helpful to have more structured information. And this particular scenario is a function which is, let's take a look. This is a function which is just doing, so we actually simplified this down. Well, actually, I'm going to keep this in here. There are two cases. We have recur in a loop and recur as in tail position for function recursion. We want to change both of these to actually use some more structure. Right now, so this is the IR for the recur that's function recursion. So take a parameter. If the parameter is truthy, we're done. Otherwise, we recur. This is function recursion, and we end up recurring I will be true, and so we'll be done. And our IR for this is to get the parameter I, and then to initialize our loop variable. Jump into our recur block, get the current loop variable. If it's truthy, then jump to done, and so this is our grab done and return that. Otherwise, grab true, set that in our loop variable, and then jump back up. And so right now, if we try to code gen this to C++, there's not enough structure. And so we get stuck in an infinite loop. Hey, TwitchGD, how's it going? Hope you're doing great. Happy Wednesday. Happy today. What am I working on? See jank IR? Yeah. So today we will hopefully be wrapping up the work on jank, on the C++ code gen for this new jank IR. And so I've already implemented all of the instructions. So we have code gen for all of the instructions, and we can do a lot. But we have a couple of things that we need to fix because they don't generate properly, and then we need to verify that everything works nicely. And so probably I'm hoping we could do the first part, which is fixing the bad code gen that we have now, and then second part, which is like getting into like battle testing this new code by compiling clojure.core and some other core libs, and then running Jank's test suite. And I'm sure we're going to find lots of issues that we can fix. But yeah, once we do this, then next time we're going to be not focusing too much on IR. Probably we're going to just be focusing on optimizing Jank. So we're 3 weeks in. 3 weeks ago, I started on Jank's IR. We had no We had no custom IR. We were just doing code gen from our AST. And so it was about 2 weeks of like designing the IR, implementing the IR, and going from our AST to our IR, and then about a week of going from our custom IR to C++. That's about what it's been, which is not bad. I'm okay with that. If I had used Claude to do it for me, maybe I'd have it done in a couple of days, and then I would have absolutely no confidence in any of it, and it would all be shit. So I'm okay. I'm okay with 3 weeks for that. So today we have this case here where we have we're doing recur. Right now I'm just doing that with jumps. This would work fine if we weren't going to C++ code gen, because going from our IR to C++, we actually need to go up a level. And so the jank IR needs to contain more structured information than I think SSA IRs normally do. And that's okay. It's cool with me. That works fine. So to do this, I want to add a new I want to put that here. I want to put that here under branch. I want to add a new instruction. And so we're going to add a loop instruction. And instead of jump here, where we jump into the recur block, and then the recur does its thing, and then at the end of the loop, we just like jump back into here. I'm going to replace this instruction, this jump, with a loop instruction. And so it's going to be a terminator as well, because it's also going to jump to the start of the loop, but it's going to contain some additional information that's going to allow us to, in the C++ code gen side, know that we're entering a loop, and then know how we're going to get out of the loop. And so that altogether is going to be useful. Another option is that I could just like attach this as some sort of metadata or something on top of the jump instruction that's here. I considered that, but I'd rather just be explicit. There's no need to generalize. This is a good lesson. Oftentimes we as software engineers feel like we need to generalize everything. And that, oh, well, if you're implementing this thing, then you got to make it general. That way it can be reusable and everything like that. If you're implementing something for a particular system and you want it to work well for that system, you oftentimes don't need to generalize it. Just make it work for that system. If you later on need to generalize it, then that's okay. That's okay. You can generalize it later. So for this, we're making an IR for jank. I'm gonna do exactly what jank needs, and not worry about maybe we could keep this as a more general thing. No, we're just. I want there to be an instruction for looping, because that's going to make it easier for me, and so I'm going to add an instruction for looping. Okay, so we to do this are just going to do a loop here and a loop there, a little bit of loop here, and then so what does a loop want? A loop is going to have the entry block, it's going to have a merge block, it's going to have a shadow variable. So it's going to be something like this: loop block, merge block, shadow variable. And then it is a terminator, because we're going to use that in place of our jump right here. And so we're going to loop block, and then this has to be called loop. And then the shadow variable is, I think, just the identifier here. And then that should be fine. So let me jump now over to here. And I'm just gonna grab all of that and then just do loop and loop. And then I'll do loop right here. Yeah, and then so we can take this, we had our loop block, and then our merge block, and then our shadow. And so we'll say the same thing here, loop block, merge block, shadow, void, and then this is loop. Yep. That's that. And then branch, so we added this new guy right after branch. Yeah, right after branch. And so right here, we'll just add that. Cool. So there's our instruction. And we can just add the print for that as well. This is just our, you could think of it as serialization. It's not really though, because we're not, it's not round trippable. But we do just use this for, right now we use it for handy printing like this to understand, but we're also going to use it for tests, I think, going forward. So we can just see what IR we had, and then run like an optimization pass and then see what the output IR is just going to be. And then probably just use closures like data structure comparisons to deal with comparing things rather than trying to implement all that in C++. I think so. So we have a loop block, we have a merge, we have a, this can change to basically be this, and this is shadow, like so. Okay, so here we have loop block, these go away, merge, and shadow. Nice. All right. Now, as part of our IR builder, we're going to want to add a function to create these instructions. So you just got to find the branch guy. Since everything we're doing, maybe call it OCD, call it consistency, call it whatever you want. But you'll notice that like in the enum, we placed loop under branch, and then when we defined it, we placed loop the struct under branch, and then like all these things are laid out in the same place because my brain likes that, because that's good for my brain. Whoops, I didn't mean to do that. Hov Sater, welcome. HOV Sater. Hope you're doing great. Okay, so for this, we could take all of this. And I'm just going to get rid of that. I'm going to get rid of that. And then here, just writing some Jai before going to bed. Ah, cool. Jai is an exciting language. You can code before bed without affecting your sleep? Question mark. Since I realized my intonation for that was a sentence. No, but you do it anyways? Yeah, I hear you. when I code before bed, I just get stuck. I just get stuck thinking about code, and then I'll have dreams, about code. And the thing is that the dreams, some people like they solve problems in their sleep with code. I don't. I will, like, if I'm thinking about code in my sleep, I don't get anywhere. Like, both in the dream and also in my, like in the real like problems. And so I just get stuck thinking about some code that doesn't make sense. And then I'll do some stuff and then that won't make sense. And then I'll do some more stuff and then that won't make sense. And then that's my dream. But the subconscious that helps people code, like for me, that works when I'm, you know, when I'm showering or when I'm walking or when I'm doing other stuff, just not when I'm sleeping. I've had 4 days of 98 out of 100 sleep scores. So today I went for a 7 p.m. coffee and code session. Ooh. Well, I don't think you're going to keep up that 98 out of 100 streak then. But I'm glad that you had 4 days of that good of sleep. Yeah, caffeine gets to me. What I say is I'm drinking a soda here, but this is one a week. This is my Wednesday stream soda. I don't. So like when I buy, you know, I don't buy soda often actually, but when I do buy like a 24 pack of whatever the fuck this is, it lasts me months. Kids who wake you up at 6. Yeah. Okay. So there's the builder. We have our loop. I typed all of that without paying attention. So let me actually just go make sure that all of that looks fine, and it does. Nice. So now we know I can also code somewhat reliably while chatting. And that was our builder. And now we just need the IR processor. So here, when we get to our, let's see, we're going to be inside of our let ref. So in Clojure, loop is actually just a let. And a loop can be used in the same way as a let. So for example, you can just say like, okay, I is equal to 0 and S is equal to foo, and then just print line, right? Like this is, you don't need to have a recur here. You can just do a let. We have a warning here like, oh, there's a loop without a recur. It's the same shit. Like they'll expand to the same code as well. But you can have a recur. That's the difference is that you could have a recur here, whereas in a let, if you have a recur, then it's going to apply to the function and not the let. So that's why inside of the AST expression for a let, we keep track of whether or not it's a loop. Just so you know, since I figure that many Clojure devs don't actually know that, because I didn't know that until I implemented it. Okay, so right here, we are generating a jump to our loop block, and then we are entering our loop block, and then we're doing a bunch of shit. So instead of a jump to our loop block, we're going to do a loop to our loop block, and then IR builder. What was that we need? So we want our loop block, we want a merge block, we want a shadow. Do we have a merge block? Shit, we got a lot of shadows as well, don't we? Hold on. Maybe all we need is just the merge block. Maybe all we need is just a merge block. I'm just going to say none for shadow right now and then not use that. Loop block, a merge block. Do we have a merge block here? Let's see. Let body. We do our loop. Yeah, we don't really have the structure set up right now on because we don't do let gen like we do gen for other doodads. So in this case, we don't actually have a merge because we are in return position anyway. So let's change this to be a scenario where we do have. So I guess we would need a loop. Let me do a loop like so, and then we put this loop in a let like so, and then I'll also use let star here. Okay, so here we have a merge block, but the merge block actually comes from because we don't generate a merge block. We don't generate a merge block for the loop. We just let it go. We just let it go. So we could generate a merge block for the loop. We would end up with another merge block at the bottom here. And then we would have a place that we know we're going to go to when we're done. So I think that we're going to need that for the structured C++ gen, because the problem is that we need to know how much of this stuff is inside the loop and how much is not, right? And at some point, the loop ends, right? And we might have some shit that's beyond the loop, like, so we don't really have that here, but let's take, for example, if we were to, I'm gonna have to just def this here because I don't have clojure.core loaded right now, or at least the full clojure.core loaded. So we'll just have to def that. But let's say, you know, this code here happens after the loop. This code here happens after the loop. And so it's happening right here inside of this merge, but this merge is coming from the if. What if we remove the if? I just want to understand what we have. If I do this and then I do this. Yeah, you see, so we just don't separate the loop, and we have a jump here. Yeah, so this is wrong because we just end up generating invalid IR anyway. Here, this block has multiple terminators. Terminator here and terminator here. So we need a merge. We need a merge branch anyway. AMWeb, hi, is this game dev? Hi, this is not game dev. This is compiler dev. Although at some point, not today, we will be doing game dev with our language. But this is compiler dev. Compiler dev is kind of like game dev, except instead of game, it has compiler, but the dev part is the same. Are you developing your own compiler with C++? Fuck yeah. Fuck yeah. That's what we're doing. Holy moly. Yeah, we are designing a language, AMWeb. We're designing a language and implementing a language in C++, and that language is a Clojure dialect. Clojure is a Lisp. Well, this unfortunately looks bad because it's a bunch of hacked up shit. But Clojure is a Lisp. And our language is a dialect of Lisp, and it's also a dialect of C++. And so it can do all of the crazy shit that Lisps can do. And it can also do all of the crazy shit that C++ can do. Which distro is this? This is, well, the distro really doesn't matter here. like the window manager I'm using is i3. But this is, for the record, NixOS. Okay, loops. So yeah, we wanted a loop here, heard from another developer cluster. I heard from another developer, clojure, here in Twitch. You know them? No, I don't know that. I don't know that name. What are you talking about? What are you talking about? Right, multiple things. We need a merge block. We need a merge block. If there was ever clojure. Oh. No, you're good. You're good. Clojure. There are only a couple clojure streamers on Twitch. The only other one I know of is Janet A. Carr, and she's like the OG clojure streamer on Twitch, and I definitely know about her. She's cool. So in this case, we need to make a new block, which is going to be our merge block. Merge block. I've done some clojure professionally. Cool. Loop merge. Yeah, I should probably do that. Merge, maybe if merge, try merge. What's this? Case merge. Nice. That's a little more helpful maybe, because we're going to end up with multiple merges. Okay, so loop now, IR builder. But I'm not just a parentheses eater for breakfast, parentheses for lunch guy. Yeah, shadow. Shadow, none. Okay, so we could do our merge block here and then none. Now, we want to do a gen of the body. Yeah, but we need to do a jump. I need to remember how we're doing this. Let me take a look at the if ref. Let me make a mark where I am right here. Let's say right here. And then let's take a look at the if ref. So we do our merge block here, and yeah, we'll use it there. And then for our then, we do our gen for our then, and then, okay, so we say if we're not in tail position and we don't have a terminator, then jump to the merge block. Word. Let's do something along the lines of something like that. Wait, and then what are we returning? If actually returns nothing. I don't actually know we want to return. We can also just return none for here until that becomes a problem anyway. Do we need to do a branch set? No, I don't think so. We need to jump here. Yes. Loop, jump. And then this else is for what? Oh, if it's not a loop. If it's not a loop, yeah, that should be fine. Okie doke. Trigger that again. Let's see. Blah, 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 blah. L value, blah, blah, blah. Const size, blah, blah, blah. All right. 402 right here. So this guy is going to be a usize. And so we need to do a block name on that in order to get an identifier from that. And they're gonna need to do the same thing here on that. And then none is gonna work fine there. And so we can kill that and do this again. Cool, that links. Compiles and links and fails an assertion. What do we got? So we are at 384 in IR processor, which is right here. We are doing an unwrap, yes. So if we grab this, we're doing an unwrap of our loop right here to grab this. And so that's why we can't return none. The problem is that we're returning none here. If we do something along the lines of body res and then not type that random shit and then return body res, that should work. The other thing is that we probably want to enter merge block here. To make sure that anything else that we start generating goes into that merge block. Yeah, we'll have to see if there's more that we need to do. Okay, let's take a look at what we got. Okay. So we ended up with our loop merge block. That's good, but we're not actually inserting the instructions into there as we ought to be. So that's a problem. What we are seeing here is here we unconditionally loop. Yes. The loop body should just contain an unconditional jump. Well, and the true, and the branch get, and the branch set. So it should just be this. The loop body should just be this. And then the loop merge should actually have these three. But it does not, right now anyway. Why not? Why are we not putting those into... So we grab the body here. Oh, is this because... No, it's not because of that. The body of the let is actually this guy. No, the body of the loop is this guy. We're in our loop. Loop. We do our loop. We create our loop. We do the body of the loop, which is this. That's our recur. And then we should enter the merge block and do everything that comes after. Enter merge block. if position is not equal tail. We don't have a jump at the end anyway, because we're actually I think that part of the problem is this unconditional thing. Let's see how this looks with let's see how this looks with like a normal loop. So we grab I is false. If I is true, then we're done. We recur true. So here's our false v0. We put that into the shadow, which is basically I. S1 is basically I. Then we enter our loop. So we have our loop block, we have our merge block, we have our shadow. Ignore that. Loop block and merge. So we get into our loop block, we grab the latest value of S1, that's I. Check if it's truthy. If it is, then we go to if 6, we grab done. We actually set S9 and we jump to if merge. Here we grab S9, we jump to loop merge. Then we print and we print S9. That's here. That's our result. Okay. So this actually looks correct. I think it's only when we have that unconditional loop that ends up being a problem with the IR. Let's see. Let's see. So let's just do our, wait. This is the one I wanted. So let's get the C++ code gen working properly for all of this. Let me put this over here, and then I don't need this anymore, and then eval. Can grab that. Okay, now we have a new instruction. And so we're going to need to handle code gen for that instruction. Branch. So this new instruction is called loop. And we'll start off by saying return none. We'll say next instruction here to skip that. And then here is where we want to end up creating a loop. So is loop. I think what we'll do here is something along the lines of yeah, something like this. So we will enter a while true. Like so. And then here we'll do a gen until jump, and this will take the merge block like so. hopefully that works. Yeah, I did spend some time cleaning up the API that we use for generating C++ from IR instructions, so that this can end up being something as clean as this, which basically just like this will grab all of the blocks that happen, you know, from where we are up until the merge block and make sure that they end up inside of this. And then we should get into this merge block cleanly and be able to do stuff after that. Let's see. Let's see. Okay, so we don't end up doing the shadow here. Where is the shadow? Let shadow. Yeah, so we actually have several shadows. We need to hang on to all of those. Yeah. Yeah, so I think we're going to do something like native vector identifier shadows, and then shadows.reserve, and then expr pairs.size, and then we'll do something along the lines of shadows in place back shadow here. And then when we create this, we'll do a move of shadows into here. And then this isn't just a, this is actually a native vector of shadows like so. And then this, we're moving it. So this is going to be an R value reference. And then here we'll have a native vector as well. This is called shadows. And then this is native vector shadows, and it's an R value reference like so. And there we go. So we just need to do this. Okay. So now that we'll have this, we'll have all of the, so this is the old C++ code gen from the AST that I'm referencing right now. And we're going to want to grab, we do this before the while. And we end up looping through all of these. Does that matter? Shadows are gonna have a type that we're gonna want to care about. Yeah, we're gonna want to, we don't have to worry about that right now, but we're gonna want to care about that. So we'll loop through for auto const reference shadows, and we'll do this. And so I think we can take that, and then this will be this, and then what do we initialize this as? I don't know yet. Yeah, we end up doing the branch set here before we do the loop. We should do the loop first. But the loop is a terminator. So we either need to embed the initial values of the shadows into the loop instruction, or we need to deal with creating the values elsewhere. Yeah, I think I'll just put the initial values in the loop instruction. So like our instructions, we end up having some instructions that end up being like more robust, you know, like and featureful. And that's just so that we can maintain the structure of the code, not lose that. But it's still SSA. Like it's still going to be viable to optimize for all the things we want to do. So I'm okay with that. And like this is very intentionally a much higher level SSA anyway. So what that means is for our shadows, we're going to need two other bits of information. We're going to need to know the initial value, V0 here for this guy. And we're going to want to know the type. Okay. So instead of just an identifier for shadows, I noticed for branch, we had this sort of shadow details. I'm probably just going to take that same dealio, except we're going to have name and then initial value, and then type like so. And then we're going to do shadow details, and then, whoops, do that here, and then do that there. And this is loop shadow details, like so. Cool. Now in IR print, this ends up being a little more annoying because now we're going to need to what was it that had the shadow? It was branch, right? No, it wasn't. Yes, it was. We'll just do something like this. So we'll do loop block, merge, and then shadows. And then the rest of this, whoops, goes like so. And then this will grab, close. You want to close shadows, and then we'll do the type like so. And here we'll just do shadows. And so what we have here is shadows is going to have name, initial value, type. And so we'll just do name and value's fine, and type and name. Maybe I should just call that value. I'm just going to call that value. And s.type. This needs to be s like so. Yes. And then IR builder. Here we want loop shadow details. And same thing here. Loop, wait. There. And then here, when we do this, we need to create a loop shadow details. So when we in place, we can't just do shadow. We need to do shadow and then the initial value. And so the initial value here is locals name. So we're not going to do this guy. And then the type. Like so. Inst loop builder. Here. Inst. Local type, CBP processor, local type. Right, because I saved all this, and this is all poo. So, yeah, shadow type and shadow name. Shadow name, and then shadow value, and b.buffer. Our processor, int, and print. Right. Yes. So we don't specify this. We don't specify this. Then we just get into shadows. Cool. So what we have now is not rendering that, but we should be. And yeah, so shadow S1 is initialized by V0 and then has this type. We do our loop. Here's our merge. Yeah. Yep. IR print. Let me just do a proper type print on this guy. So get qualified type name on that. And then what we can do, let's see. So we enter our while, and then the other thing is that we enter a new scope for each and every one of these, So we're going to need to do a new scope at the end of these, if I'm not mistaken. Yes, we are. Because we create a new scope for each to allow for shadowing. Lots of shadows. More fucking shadows than a ray tracing demo. Aside from that, I think it works. I think it looks right. let's take a look. Kill. Yeah. So let's take a look. So I starts at false. Here's our false. I is v0. And then we are not generating the body of this yet. And that's okay. So I'm not expecting this code gen to be correct. But when we look here, oh, this needs to be in quotes. Ah, fine. Print type quotes. Okay. But yeah, otherwise good. Otherwise good. So CPP processor, why are we not generating the body inside of this while? What do we want? We want to generate until we find our merge block. Okay, what is our merge block? Do we have a merge block? Yes, we do. Loop merge 3. So we jump to loop 2. What we ought to do here is, okay, so we do next instruction. So we're currently on this loop. We do next instruction. What we ought to do here is enter block and then inst loop block put us where we need to be, and then generate until we find the jump to loop merge, which is going to be zwing, and then zwing and zwing, and then zwing. And then we're going to once we're done with all this, then we're going to merge block. So we'll just say if inst merge block is sum, then enter that shit. Okay. And then here I was earlier saying like, oh yeah, I've been working on the API for this. That's why it's just 4 lines of code. And then it's like 4 times as long now. I just didn't have all the things I needed to have. Okay, cool. So now we generate a whole bunch of stuff in a loop, and then we crash. So this is progress. So the problem here is we see we're in this loop. We have truthy, branch, literal, branch set, jump, branch get, and then we loop again. And so the truthy you can see is the sort of a cutoff for where this ends up repeating. All of this right here is repeating up till the next truthy. So we're as we're trying to generate this, we're not doing a good job. We are not doing a good job. Enter the loop block. we generate until we find a jump to the merge block. If we have a merge block, then we enter that and we continue. Here, let's take a look at the intentionally throw. Because right now there's way too much backlog to even get to where it was printing the IR. So I'm just gonna stop before we print all of this. So I can see the IR. Maybe I should just hang on to this. So we enter our loop 2 here. And that is right here, enter block, loop block. And then we generate until we find a jump to our loop merge. So we're gonna do this, we're gonna find our branch. We're gonna do if 5 and else 6 here. Here's our jump to our if merge. Here's our jump to our loop merge. And then here, yes. So it's because of the jump back to loop 2 in the else that ends up giving us the, yes. Okay. So this is our problem right here. As we're doing code gen, we're just going from instruction to instruction to instruction. When we do this right here, when we do this gen until jump, we're just generating the C++ for each of these instructions one after another. And when we hit jump, we just go to the next block. You know, like we go to the block that is suggested here, loop 2, and then we just keep going. But that is putting us in a loop. So like one way to do this is like, okay, like keep track of the blocks we've already been in. But I don't think we should need to do that. I think another way is if we had a way to say, for this gen until jump, right now it's looking for a jump to this merge block, but it could also be checking for a jump to multiple blocks. So maybe if we just specify multiple blocks here, then we could specify the loop block and the merge block here. And then that way, here, when you jump to the loop, like that'll be, or that when you jump to loop merge, that'll be like we're done with the body. And then here, when you jump back to the beginning of the loop, that's also done. Yeah. So let me mark this. And then here, I'm just gonna do another version of this function, I think. Let me see. Native vector, jump blocks, and then so here we'll just say like, okay, if this is a jump, and then we'll say, okay, so for autoconst block in jump blocks, if we'll call this jump block, if jump block is sum and blah blah blah, then break. Okay, and so then here what we could do is we can provide multiple blocks. Okay, let's try doing this. We still loop forever. I need to step through that because I don't see why that would be the case. Here, we should only go until we find a jump to if the jump block is sum and the current instructions block is equal to the jump block. That seems reasonable to me. But yet we still loop forever. What are we looping over? So here's our branch get, truthy. So here's our branch get, truthy. And here's what I'm gonna do is I'm just gonna grab all this. And then just do a vnew here. And So our branch get is basically here. Branch get truthy branch, and then literal. So we are on to here, literal branch set. Okay, and then we jump to here, and there's our literal true. So we're on to here, and then branch set, and then jump block 2, and then we're back up to our, branch get here. And then that's it. Yeah, so we're not stopping when we see this jump to loop 2 here, when I would expect that we should. All right. Well, I will. I'm gonna step away for a couple of minutes, and then I will take another look. Sorry for the freeze. I'll be right back. We're back. Okay. What's going on? What the fuck is going on? What's he building in there? Yeah, I think we're better off just doing a $980. Okay, so what is loop block? That's loop 2. That's what we're expecting. Loop 2. So here, this jump to loop 2. Yep, and then merge block. That is loop merge 3. Right, that's our ending. So this is our loop block, this is our end. Okay. So this shit in the way. Finally. So grab our instruction. Here's branch get. And so our next one, let's just take a look here. It's going to be truthy. Yep. And so then we're going to have our branch. I see. I see. I see. So the problem is not actually here. The problem is when we try to handle the if itself is also generating until it finds its own jump to the merge block, and instead it's finding the jump, it's finding the recursive jump. And so then the loop for the if is getting pulled into the infinite space. So again, we could solve this by keeping track of blocks we've seen in the builder. We could also keep track of this by keeping track of known loop blocks. Yeah, keeping track of the scene blocks, we can actually do that automatically because we have this enter block function right here. And we do that whenever we want to handle a jump, or whenever we're piecing things together. we could just do it automatically inside of there. Whenever we enter a block, we just say, yep, we've already entered this block. Do we only use one builder per function? No, we use a builder per module, which would mean that we would need to clear that out per function right here, which is fine. Maybe we do that. I'll give that a go. It seemed a little crude, but sometimes that's just the way to do it. So if we do a native set of I think I can actually just do an identifier here. Scene blocks. And then when we enter a block, we just say scene blocks in place block. And then clear it when we need to. Then now the problem is we need to handle knowing, so like we know now when we've seen a block, we need to handle checking in the correct places. And so that would be in gen until. So first off, I don't think that we need this guy anymore. I don't think so. I'll keep it around just to be sure, but I don't think so. And then here, so what we want to say is, if we are in a jump and that's the one, if scene blocks contains, I suppose we could just do an or here, or, whoops, comp block. That doesn't sound like what I wanted to do. Yeah. And then gen until jump. This guy, we can just try putting this back. Maybe. We'll see how this goes. So clojure conj dates were just announced. Any of you folks in chat going to clojure conj? Killing this and then run this without GDB. Okay, so we don't infinitely loop anymore. That's great. That is great. And then the only problem here is that we're using S8 undeclared S8. S8 is declared and defined here and then used here. Where else are we using S8? In here. Okay. So the problem is that we define this inside of the loop. Okay. Not bad. We're close. We're close. We can definitely see this coming together now for what it should be. Let's take a look here. So I think I want to see the IR, and I'm going to get rid of this guy. So here, S8. We use S8. Where is S8? S8 is from the shadow of the branch. The branch, which is why it shows up above. The problem is, so in SSA, you can just have you can have S8 up here on line 10, and then you can use it anywhere below, pretty much. And so we're using it here, we're using it here, we're using it here, and those are all fine. But the way that the code gets generated, S8 is inside of this while loop. And so at the end of the while loop, we end up not having access to SA anymore. So the solution here is that we need what is this S1? S1's not used anywhere. Why are we signing S1 here and S8 here? S1 is here. Because this is the recur. Right. Yes. So the solution here is that we need a shadow variable for the loop, so that when we're done with it, we can have a value which resembles the result of the loop itself, thus treating the loop as an expression. And we don't have that right now. And then that value will exist outside of the loop body. Okay. We're close. We are close. So shadows, I kind of want to call these like binding shadows. And then I kind of want to do the same thing with this. Well, that was really successful. Thank you so much for that. Doing that exactly the way I wanted you to, where you renamed it in all of the places that it was used. That's exactly why I used that tool. And then, yeah, so we're going to have separately, we're going to have a shadow, which is the resulting value. This will need to be an option as well. Because in return position, tail position, we're not going to have one. Swap those, shadow, okay. So IR print, so we're going to have here, we're just going to have like shadow, and we're going to drop that and then shadow and then grab that, and then we're good there. And then IR builder here for loop. Like so, okay. Close that. There we go, loop shadow, plug that in. Now, so if we don't have a terminator, then what we need to do is we need to do a branch set of our shadow, loop shadow, and body res, unwrap. And then inside of our loop block, we need to do a branch get of our loop shadow and the type. Do I need to know the type? Yes. That's not gonna be always correct, but we can get around it for now. Hey, Bad Time 100. I hope that you're doing well. Welcome to the stream. Hope that you're having a good time. And not spilling water on yourself. Code compiles and links. I had no idea you were a streamer. I don't know if I would call myself a streamer, but I do stream once a week. It's, you know, like you can push your code up on GitHub and you can do blog posts, everything like that. But I find that, you know, I've been trying to do the streaming just to allow people to interact with jank development more, interact with me more, as all this is being put to the hammer. Sorry, I stopped mid-sentence because I started reading code. Or that you stream at all. Yeah. Well, glad you found us. Welcome, 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 welcome. So now, let's take a look. So now our loop has this shadow S1. And so everything should be end up assigning to S1 by the end of it. In our loop merge, we do a branch get of S1, and then That's our expression. You have to run now, but I know you're here. I'll catch him sometime in the future. Oh, no problem. Hope you have a good day. Thanks for stopping by. So where's our S1? Right, we gotta actually, so now that we have a shadow for our loop, we need to generate, that. We need to generate the, so we just need to say if inst shadow is some, then we don't even need this shit. We do need the type though. We really do need the type, I think. Whoop. Yeah, we really do want to just do a one of these. So we're gonna need to do an unwrap on that, and then like so, and then inst shadow, and we're gonna want to do an unwrap on that. Hey Johnny, how's it going? So let's change this to be, I don't know if I want to pull these out into like a helper thing that we can just use in one place. I think so, because it's looking like it's basically the same shit. Probably some detail thing. Whoops. No point calling it shadow details if it's in a detail namespace. Lucky to catch a stream. It's 12:28 p.m. Wait, do you mean AM? Do you mean the middle of the night? That would be 12:28 AM, right? 12:28 p.m. is like lunchtime. Is midnight? Yeah, that's AM. That is, hey, I can't blame you. It's midnight. So yeah. Well, honestly, Johnny, I use 24-hour time as well. Like, let's see. Can we, I don't even know if that's going to work. There's my, well, I'll wait till the stream shows. Yeah. See, there you go. I even got a reminder to Twitch stream. But Johnny, most Americans don't. We don't even call it 24-hour time here. We call it military time because only military people say 1800. Okay, there's the shadow details. So we just want detail shadow. Maybe just call it typed shadow. Detail typed shadow. And then we'll do the same thing here. So this will be a, wait, no, not here, here. Detail type shadow. I'm glad that you could join us though, Johnny, even though it's the wee hours of the morning for you. What are we working on right now? Still some kind of custom IR? Yeah, so we are very close to having the C++ code gen for the custom jank IR work. And by work, I mean like for every single AST node, for every single IR instruction, being able to compile a clojure.core, we're very close. So I'm fixing a couple of issues right now that are around recursion and how we represent that in terms of IR instructions, and then how that gets turned into C++ code. And so that's caused me to need to rework like how we handle the loop. Like we didn't have a loop instruction when we started the stream, and now we do. And we just need to encode more information inside of these instructions, so that way we can reconstruct all of this into C++ in a structured way. And that is what we're working on right now. So yeah, we should be good to merge like all of this custom IR stuff and like strip out I don't know what it's going to like, strip out the 12,000 lines of code gen that we have for LLVM IR and C++ from the AST. Like that's going to be a net negative PR, I think, which is going to be pretty slick to move from those two code gens to IR, and still C++ code gen should be net negative. Could MLIR help with this? I know it exists. Yeah, it's possible that we could have used MLIR, but MLIR, when I looked at it, was just really complex, and I knew that what I needed was pretty simple. So I did it my own approach instead. I consulted with a Clang dev who I have been working with the past few years, and he also suggested MLIR as something I could look into. And I asked him like, okay, so should I use that instead of my own IR? And he's like, I don't really know. And I was like, okay, so like, do you know much about MLIR? And he's like, well, I've been to a few like, talks about it, and like been in a few meetings about it. And I still don't like have a good picture of how it all comes together. And I was like, oh, okay, that's kind of how I feel. So yeah, I opted to do it my own way. I think that, so I've been working on this for 3 weeks now. And I was saying at the beginning of the stream, Johnny, like I was about 2 weeks of designing Jank's IR and implementing AST to IR conversion. And then about a week of implementing Jank IR to C++ code gen, and dealing with the the issues that come up with like, oh, need more info in the IR, blah blah blah. So that's not that much, like to the point where if we needed to down the road, if we're like, oh well, maybe we like use a different IR, or we go from Jank IR and start generating MLIR, like lowering to that. I don't know. Like I think there are a lot of options there, but yeah, the main thing I know is like I wanted Jank's IR to be really high level, so that we could do things that that operate at the clojure semantic level, and when I do it myself, I get to operate at exactly that level. I don't care about optimizations like memory to register, for example, because like our IR doesn't even have a way to like allocate stack memory. We don't even have those concepts. Anyway, what was I moving? I was doing shadow details. Dun, dun, dun. Type shadow. Dun, dun, dun. B-tail. Okay. Okay. I got totally sidetracked in the middle of this, and so this is probably not going to compile, but that's okay because we have a compiler that's going to tell us all the places that we fucked up, and then we're going to fix those. So builder 103, IR builder. Yeah, I haven't even gone into builder yet. So IR builder 103 right here. Yeah, so this is going to be inst detail typed shadow, right? Or is it IR detail? Ah, it's IR detail. And so this was IR detail. How often do I commit changes? I commit pretty regularly. So on stream, I commit less often just because it's a pain, because I want to commit like off screen, like because I have GPG signatures, everything like that. But we can see here, so today's the 8th. So yeah, yesterday I made 1, 2, 3, 4, 5 commits. So yesterday, like in working, so we can see here, this was 11 in the morning and this was almost 10 at night. So yeah, like I try to commit pretty often, and then because committing and pushing is kind of like I get relief from that. Because I just have this background anxiety of like, oh, what if my computer explodes or something, and I've just spent a week like doing this refactor or something like that. So instead I commit very often and then I push. And then when I merge pull requests, and everything goes through a pull request, when I merge pull requests, all that gets squashed into one commit anyway. So I sometimes make commits with 50 plus files changed as well, Johnny. But that's just because I'm just going through a whole bunch of files to, like, if I want to change all of the instructions or all of the AST expressions to have a new thing, then that's going to be 50 files change. But I think I try to measure my commits in terms of like time spent and not so much in terms of like files changed, right? So it's like if I commit, so that was 4 times in a day yesterday, which is something like every, well, that was like, I don't know, 10 hours. And so then that would be like every 2.5 hours, basically. That feels pretty good to me, like committing every couple of hours. And when I commit, I push as well. And so that would mean that ideally, worst case is I lose a couple of hours worth of work. If something goes catastrophically wrong, I lose a couple of hours worth of work. Now, if one of those commits has 1 file changed and the other commit, has 50 files changed, that doesn't matter so much to me. The main thing is like, I commit so that I don't lose work. Our shadow builder, sure. Yeah. Okay. Hold on. So this guy is, we're already in IR. So detail, type shadow. And then loop. Right. It's actually this one that changed. Hey, Cordum. Welcome. Hope you're doing great. With a name like Core Dump, you must have some native development trauma. I hear you. Okay, so this, we were creating these guys. Now we want to create, wait, do we need IR there? No, we do not. So we want a detail typed shadow. Detail typed shadow. Thanks for the sub, Johnny. That's great. Enjoy your ad-free viewing. Unwrap or in IR print. Speaking of ads, I switched all of everything to pre-roll, so that way we don't have any interruptions in the middle of the stream. I know that pisses off some people, but either way pisses off people, because like you have people who prefer mid-roll ads, and then you have people who prefer pre-roll. But for me, it's like I'm not doing this for. I don't want to show you guys ads. I don't want to be interrupted. I want to have a conversation and develop all of this and have you guys follow along. So I'd rather just like get the ads out of the way in the beginning and then have the entire rest of the stream for us to just, do the thing that we're here to do. So if you don't like pre-roll, but yet you still manage to join, that is why we're doing what we're doing. And yeah, it hurts the visibility, because other people are going to try out, like they're going to click on the stream to see what's up, and then they're going to get ads, and then they're going to click away. But I don't make the rules. Okay, so for loop, we have shadow struct loop. Yeah, so shadow, this is an option. And so that's going to be shadow, and then we're going to have so we just can't do that. So we're going to have to do something like this. That's really stupid. Checking out a new stream, boom, ads, you're out. Damn. Yeah. The thing is, like, I totally get that. I totally understand that. But when you think about it from the long term, in order to not have pre-roll ads, you need to run 3 minutes of ads every hour, at least. 3 minutes of mid-roll ads every hour, which means in order to not give the newcomers pre-roll ads, you need to give all of the other people who are already on the stream 3 minutes worth of ads every hour. And so everybody who's already on the stream needs to pay 3 minutes of their time and interruption in the stream so that newcomers don't have to have pre-roll ads. So that newcomers don't have to have, what, 30 seconds of pre-roll ads? It's not worth it. It's not worth it. I feel like that's not respectful for like the people who are already on the stream. I don't know. Okay, so instruction 232. Yeah, what doesn't line up here? We have our shadow here. It's not respectful as business. Yeah, I'm not here to make money though. I'm here to, I want to make money working on Jank, but I don't want to make money by making you guys watch ads. I'd rather have like a company with established revenue pay me a salary, and that could be my money instead. No, I don't. I think of all the streams on Twitch, you're not likely to find me vibe coding. IR Builder 349. The thing is, like, coding is my favorite thing to do. Coding is my favorite thing to do. Why would I have something else code for me? Yeah, there was that great meme. Did you guys see that cuck coding meme? That's kind of how I feel. Except I don't want to give up my spouse for someone else. I want to give up my project, someone else to fuck. IR processor 407. Okay, so now we just need to type here. So type shadow, we have the name, and then we have the expression type. And so the type will just be the expression type of the let itself. Okay, everything should be put together now. Fucking types. All right. Okay, so it's been 1 week. Okay, right. So now we have our shadow, and so now we can assign to our shadow. So here's our loop. We have our shadow S1. And then in our loop merge, we can get the value from that. And in the if merge, we assign to S1 the result of the if, which is S9. Perfect. So here we're about to do our loop. Hey, Super Skullin, welcome to the stream. Hope you're doing great. About to do our loop. We have our S1, which is going to be our outcome of the loop. And so we do our loop. Here are our bindings for the loop. So just S2 for now, because we had I. So I is S2 basically. And again, I haven't focused on like naming these yet at all, so I don't care. We initialize I to V0, which is false. Enter our loop if current value of I is truthy. Here's our V10, then we're done. So S9 is the result of our if, so we grab that. Otherwise S2 is equal to V10. Now S1, yeah, it'd be great if we had a continue right after this, because we have a jump. We don't actually need it, I think. But we're going to end up doing extra assignments to this. Okay, noted. That's pretty small potatoes though. That's what she said. So we're not going to worry about it. And then we're using 9 here. We're using 9 here, but we want to be using 1. So this is going to be an issue with right here. So this is an issue, I think, with the IR, because we're using 9 as the result. We're using 9 here for R. That's the result of our loop. Is that just because we are? What are we returning? Aha. But what we want to be returning, I fixed it. So what we return here for each of these, this is when we're creating our instructions. Wait, why is this an error? Constants of blah, 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 blah. All right, fine. Named return value optimization. Yes. Okay. Nice. Okay, so this case works now. And so now we just need to try this same sort of thing in return position, like so, which is probably not going to work. Okay, well, it didn't fail. Let's take a look if see if it's right. So we'll take a look at our IR first, and we'll just so we're in a function reverse. We have our loop. I starts at false. If I is truthy, we're done. This is gonna return done right here, because this is in tail position, because the loop itself is in tail position and the if is in tail position, which means each of these branches is going to be in tail position, and then otherwise we recur. So here we take our false, we enter our loop, and we start S2, yeah, these are our bindings. So I is S2. S2 starts at false. We grab the current value of S2. If S2 is truthy, then we branch to if 6. We don't have anything in here. We need to remove this. We need to remove this if it's empty. Not a big deal. Not a big deal, but we can do that. So if S2 is truthy, we go to if 6, where we grab done and we return. Great. Otherwise, we go to L7. We grab true. We update the value of S2. We jump back to loop 3, which is good. Get the current value of S2 again. Check. Blah, blah, blah. So the IR looks good except for this loop block being here. This loop block should just be gone. Let's take a look at the generated code. So V0 is false. S1 is the result of our loop. It starts at nil. S2 is our I variable, starts at false. And then we check if it's truthy. If that is true, then we grab done, we return it. Great. Otherwise, we grab true and we assign it to S2, which is our value. And then we loop because we are in a while true. Then we check if it's truthy. Yeah. Cool. So the only problem that we have here is this extra IR block. And the extra IR block we can fix pretty easily. All we need to do so right here, we have our merge block. And we need to say whoops. Oh, also we have a to do here for the correct type on this. Do I have that type now? This is the type of the loop, which I should have. It's just the expression type of the loop expression itself, which is fine. Yeah, and then so here I can do remove block and then merge block like so. And let me so this says if we're not in tail position and we don't have a terminator, then jump. Yeah, so here we're actually smarter. We've separated these. We should do the same thing. We should do the same thing here. So I want to grab these two. I want to put them here. And then I want to grab these three. Enter block, branch get, return loop shadow. That is going to handle all of our cases better. Okay. Okay. Now, so we hit an error during code gen that we can't find loop merge for, and we can't because we removed it. But the problem is the loop instruction here still says that it has a merge, but it doesn't. We remove the merge. And so we just need to, that's why we have an option set for the loop instruction. The merge and the shadow are both options. We just need to conditionally specify those. And so what we'll do is a little bit of ternary. So we'll say if we're not in tail position, otherwise, JTO option for identifier. And then the same thing we'll do for this. I think we'll just grab this, put that there, grab that. But we'll need to do that. All right. Interesting. So when we don't have a merge block, yeah, so this was the original problem that we had when we were in an infinite loop. So when we're in a let, this is going to work fine. Yeah, so one thing that we can do, we always have a fallback here. The fallback is we could always just require a merge branch. Right now, we have a special case that we're doing for each of these instructions, and we're doing it for optimization reasons, but it doesn't have to be done. That special case is so when you have like an if, like this, for example, so we have a branch right here that goes to if 6 and else 7. So if 6 and else 7. And then each of those has a merge branch that they're ultimately going to converge onto. And we know this at the actual branch instruction because we keep track of all this stuff. So we know like, okay, so we're going to either go to if 6, we're going to go to L7, and then ultimately we're going to converge at if merge 8. But the problem is if the branch itself is in return position, then we're not going to have a merge because we're just going to allow the branch, each of these branch blocks to generate their own return instructions. And we do that so that way we don't need to propagate the data that would be returned into the merge branch with a phi epsilon and then return it there. So it's just an optimization so that we don't need to pass as much data around, but it does end up complicating these things quite a bit. So I don't yet know if it's worth it, but I've been keeping it so far because the whole reason we're doing this IR thing is to have things be more efficient. So been trying to keep that, but here it's biting us. So let's take a look again. at this case and see if there's anything we can do about it. If there's nothing we can do, I'm just going to require that we use a merge. There's already one instruction that I've required that we use a merge for. I think it was case, or was it try? There's one of them. There's already one that I've required this for. Just because trying to make it all work otherwise was just too much of a pain in the ass. So I just want to take a look at the IR here. So yeah, our loop doesn't have a merge. It doesn't have, and so it doesn't have like a shadow variable, which is going to be the result either. And so inside of our loop, we get the current value of S2. We check if S2 is truthy. We branch on that. And then if 6, so if it's truthy, then we're just going to grab done and we're just going to return right away. So there's no merge. There's no merge that the branch has either. So the branch is also no merge. And then otherwise we grab true, we put that inside of S2, and then we jump back to S3. So I would expect that this would work as is because we've entered S3 before, and so we should have marked S3 as seen. And so when we try to jump into S3 here, I think it's possible that we do some additional logic inside of this jump to make sure that we're not going to a place that we've already been. I don't know if that is what we want or not. So we could say something like, if scene blocks contains inst block, something like that. This should categorically fix this problem. But I'm not entirely confident that there won't be some sort of side effect of that. Okay, so I want to comment that out. We'll see. This error that we're seeing here is because we're not compiling all of clojure.core with these changes yet. We have a stripped down version of clojure.core because then I was hitting these recursion problems, and so I have a stripped down version of that, which then doesn't define the NS macro, which then when we try to compile Jank's in-REPL server, we don't get that. Yeah, interesting. So is that because I did that too early? Yeah, it is. So if we do next instruction, maybe that solves the problem. Because basically each gen function is required to handle moving the builder forward, however many instructions is necessary. And normally we do that in this for jump by just entering a new block, and then that is going to change. You think about it as like changing the instruction pointer. But in this case, we don't, because we don't enter the block, we just return, but we still need to like move the instruction pointer forward 1. So we'll just do that unconditionally here. Nice. Okay, so no more errors, no more infinite loops. And let me just double check. Yeah, so this is in return position. Let's just take a look, make sure everything looks good. So we don't have a merge block. We don't have a shadow variable for this loop. We don't have a merge block for our branch. We get the local, we have the value of S2, check if it's truthy. If, then we get our done, we do our ret. Else we get true, we put it in S2, and then we jump back to S3. Cool. Let's take a look. So one of the things that we're doing here for let, we simply don't need to be doing anymore. Loop. We can delete this whole thing. So you'll notice that there are these extra extra like curly brackets. And so we used to do this in Jenk's code gen around each of these, like each new local you define, we would do these additional curlies. And that's because inside of nested scopes, C++ allows you to redefine variables. But when we're getting our names from SSA, by definition, they all have unique names. So we don't need to worry about shadowing anymore. Cool. So now that goes away. And so we grab false, we initialize S2 to be false, accidentally paste in the terminal, and then we enter our loop. If S2 is truthy, then we grab done and we return it. Otherwise, we grab true, we set S2 to it, and we loop. Cool. So there's actually, you'll notice there's no return at the end of this function down here, but that's just because it's not possible to get there. There's no break here. The only way that you break out of this is to end up in this case where you return. And it's up to our IR to ensure that, like, this whole thing is sound. And as far as I can see, it is. It is. Okay, cool. So with all of that said, can we now actually compile this function? Because what we had before was when I tried to do jank phase 1 compile module clojure.core target build core libs. We can. Nice. Yeah, so this function is this one right here. This reverse function is what was giving me the problems before. This is one of the very early functions in clojure.core that we defined just to help us define some other shit, and it ends up being this. Empty list collection. Intern var. So we haven't, with this SSA based stuff, we haven't optimized var interning yet. So we're still just going to like intern and deref every single time. That's fine. Just haven't lifted any of that stuff yet. v16 return s5. S5 is our first binding. Yeah. ACC. Oh, brother. Nice. And this is just defining all the vars and all of their meta. Sick. Cool. So are we able to, I mean, no way, right? No way that we're actually able to here. Oh, yeah, we already have an error. So this was saying invalid use of v2 in clojure.core list. So all these functions, reverse, concat star, list qmark, list. Here's v2. So this is the one that is incorrect. Yeah, what is v2? Interesting. So this is the function, I believe. Yeah, just clojure.core list. So let's grab that. And I'm just going to take all this. We have, okay, so we have a C++ call. Let's take a look. Nope. Let me go back here. Bring all of that back in. Okay. Now we can do this. So, oh, and then smack the mic. And then, so v2 is an into object. Okay, so first off, I really like this IR printing now, because we're able to see at like something that's very slightly, well, in some ways it's slightly higher level. In some ways it's a little lower level. Instructions are slightly higher level than C++, but the blocks are slightly lower level than C++, which is kind of why it's a little odd to stitch them together. But reading the instructions in Jank's IR is really nice, because it's like you can just fucking read it, you know, and it's and it conveys exactly what it's gonna do. I really like that. So we have this function, and we're going to grab our parameter args, and then we're going to call a function on it. This is not very helpful where we say no here, but yeah, don't worry about that. I just don't know. I just don't quite know how I want to render this. And then we give it v1, v0, and then that gives us v1, and we have that here. But then we do a v2, which is an into object. Why is that not done? Is that not a into object right here? Oh, okay. So this is a slight difference between how Jank's C++ code gen used to work and how it works now. So when I ported over the code, we didn't quite get that right. So we would comment here, like basically the problem is we have a persistent list. We have a persistent list ref, which is a jank object, and we need to return an object ref. And so what we see here is that we have this into object instruction, which is basically going to convert this persistent list into an object ref. Maybe we should just like not have this instruction at all. But what we have now is a check for like, okay, well, if we're converting from like a typed object, which is what this persistent list is, to an untyped object or a type erased object, which is what object ref is, then there's nothing for us to do really, because the C++ compiler can do that automatically. Like we already have implicit conversion set up for those types. So there's nothing that we need to do for C++ code gen. But we just need to make sure that we need to do it properly right here. So we grab the name, and then we should grab should we just have a value, I think. And then yeah, and then I'm just going to reference that like so. Yeah, now whether or not we should actually have an instruction for that, to me it feels like we should. I don't think we should have an into object instruction here when we already have an object and we're just going from one object type to another. So I would probably want to change this in the there we go. So now at least we grab v2 and then we just initialize it with v1. That'll work, but it's not ideal. There are a couple of things that we're doing that are like bleeding in from the SSA into the C++. So for example, we have an instruction to load parameters. And so we just take, okay, args parameter, and then that becomes v0. And so we grab the args and then we call it v0, and then we use v0. But like, we should just use args, right? That's what we would normally do. But right now we're just going directly from the IR, to C++, and so it comes at this cost. I think we can do some more with this. Let's take a look. I think what I'll do is I'll take a restroom break and fill my water, and then we'll take a look at why this is showing up right here. Just see if it's a quick thing that we can remove. And then we'll continue compiling more clojure.core. I'll be right back. Be right back. All right. I don't know which orientation I had my back pillow in. None of them seem right. All right. Okay. So we were doing an into. Where do we create this? This would be a CPP conversion right here. Yeah. Yeah, I'm not going to worry about that. This comes from analysis land. And it's something we can clean up later. Good for now. Good enough for now. Okay, moving on. I'm going to try to enable all this again. Okay. And then we are failing with some other shit. So clojure.core last is the problem. And we're doing an auto SS. Let's take a look at last. Lasta. Next S, first S. So can we do this? Wait, what's the problem here? Last, yeah. But didn't I save this? Oh, we still have problems. I see. Okay. Let's just do... Is that fine? Can we do that much? Yes. We can. Okay, so this uses next and first. So I just need to do next and first. Like so. Now we should be able to do this. Yeah, let's take a look at what's going on here. So for what we're trying to do is we have a function that takes in parameter s. If next s is truthy, then recur with next s. Otherwise, first s. So we grab s. We set up our shadow variable. S is v1. Why are we doing S as S here and not S as v1? We do S as v1 right here. That doesn't make sense. Also, we have, wait. Okay, so this is for function recursion. And we end up creating a binding, a local binding for each. Aha, aha, aha. Okay, so when we have function recursion, what we need mutable variables. And from the old code gen, we used to create our own mutable variables based on the parameter names. But what we want to do now is actually just mutate the parameters in place. And so now we're kind of doing half of one, half of the other. We just need to fully do the right thing. So let me find, this is going to be where we're generating the while true. We should have 2 while trues. So here is this. And then also we could get rid of that. And then also, why is this a fucking raw string? Can that just be that? Yes. And then if it's still recursive, just close that. And okay, that should sort us out. Leo likes coding. Hey, how far are you into this language? I'm pretty far into this language. It's not production ready, but people are already using it to make some simple games with OpenGL. So it's definitely usable on main right now, and we have precompiled builds on Mac OS and Linux and Windows actually these days, but it's still very much under heavy development. Okay. So we do a set of S0 here. Always wanted to make your own lang, got pretty far into it before you realized you used too much of the internet and didn't really understand what you'd written. I get that, Leo. I think that there's certainly an uncomfortable period when you get into like learning some technology. Programming language implementation, compiler design is one of them for sure, but also applies in other areas like jumping into a Unreal Engine or something like that, where you're kind of going through the motions that you've learned to repeat, but you don't fully understand why repeating those motions does the stuff that you need it to do. That comes with time though, you know? Like when we first learned how to code, like when I went to school and they were teaching C++, in college, like they're like, okay, so you do pound include IOStream, and then you do like using namespace std, and yeah, they taught us that. And then you do int main, and then int main takes and then you like, they give you an incantation, and you don't understand what it all means. You just know like, okay, I need to type all this out. That's what starts off my program. And it's not until later that all of the pieces start coming together that you really get it. And so for me, like I can empathize with that. But I would say like that uncomfortable period does go away if you keep pushing through it and systematically, try to break down those parts that you don't get and fill in the blanks, but that's a lot of work. It's a lot of work. Learning new things in general, right? Like we get, especially as adults, I don't know how old you are, but especially as adults, we get comfortable, and then trying to learn something new is uncomfortable. Still in 12th grade. Yeah. Well, you got plenty of time. You got plenty of time. Okay, so what are we? I don't know if we need I think we want to introduce a loop instruction here at the top where we have this jump. So if the function is recursive, then we have a while true. Yeah, so we're basically just kind of like hacking in the same thing that we did for loop, but we're doing a half-assed job with it. So instead, if we did a loop instruction here, right here. So if it's recursive, then we're doing a jump to the recur block. Here's our recur block. And here we should just do a loop instead. So loop needs a merge block, a shadow block, and then the bindings as well. Is recursive? The body contains a recur to the function itself. Exactly, Johnny. So we keep in mind, like the part of the analysis for jank, function contexts have some bits that are useful, including like if it's recursive or if it's named recursive. So if you use the name of the function to call itself, recursive can only happen in tail position. Named recursion can happen anywhere, and then we'll have other stuff in the future, like whether or not the function is pure. But yeah, this can change how we want to do code gen. So for loop, we want the merge block, the shadow. Do we have a shadow for the whole thing? Do we need a shadow for the whole thing? Yeah, I guess so. If the function is named recursive in tail position, does jank optimize it to use tail recursion instead? Yes, so we won't like convert it to recursive, but we do handle tail recursion in, but we do handle named recursion in tail position. So in order to get we're gonna need a merge. We're going to need a merge block here. Loop recur target. Loop block. I don't remember what this loop recur target is. And I have not done a documentation pass yet. Maybe it's time as things start slipping my mind. Welcome, KH Sora Pro. Hope you're doing great. Hope you're having a lovely day. That was our goal achieved, right? Yeah. Nice. So we need the shadows. Shadows are these, the name value type. That's fine. Yeah. I think what I'm going to do is I'm basically just going to yoink all of that and then drop down to here and see what we can do. Let me just put it inside of one of these. And we'll see what we can fill in. So we're not going to do these. So these are our shadows, and arity param size, and then we here shadow name type. So we'll do type and then shadows. Okay, so we're just going to do our loop. Do we call it? Yeah, that's fine. We've already set our, that's a function recur target. That's a loop recur target. Noted. All right, and then because we're dealing with a function here, everything is presumably in tail position. Let's just assume that we have a merge block. So we'll go here. So the type of every param is always typed object ref type. Okay. And then we do our body here. And then we have all this shit that comes after. Okay. I'm gonna piece all this together. Yeah, because function recursion is very similar to a loop, but we don't actually generate, like, maybe it makes sense to just generate a loop instruction. We know that's what we're doing. But is there a cleaner way? I don't think there's a cleaner way. So let's bring this together. We grab our shadow for the full loop shadow. I'm gonna call this recur shadow. And then we have all of our individual param shadows. And then we have our recur block. And then we have our recur merge. Then we do our loop instruction. We have our recur block, merge block. We have our shadows. We enter our recur block. We do a bunch of branch gets. Okay, then we generate the body. We shouldn't need that. No, we should need that. Okay. So if now this is, we don't have an expert position, but we can check the current block. So we could do body res like so. Jump merge block. Why does that not look right? I think I want this to be here. My curlies are not lining up. Okay, where are we at? It compiles surprisingly. Okay, this is a syntactic problem. I don't know where we're doing that. Nowhere here. But let's take a look at the IR first. So, I don't know why we have this here. Why are we starting with a shadow branch set? Ah, right here. Oh, okay. Yeah, we want to remove this because we should be setting it as part of this here instead. Okay, so we remove this. And then move that down here. Okay. Then our loop block is recur for. Here we get the value of S1, good. We get next, we call it with S1. We check if it's truthy. If it is, then we go to if 7, else 8, there is no merge. Yeah, that's not right. This isn't right either. We're doing a branch get here when we need to be doing a branch get here because we're not entering the merge branch before we do our get. We're doing our get right here, so we need to do enter block merge block. And then rather than just values empty, I'm just going to say if the current block has terminator. So if the current block doesn't have a terminator, then we'll just return no. Okay. So we grab our parameter s, that becomes v2. Done. And then we have our loop. We have our output of the loop is s0. And then our binding is s1 that starts at v2. So here's s0, this can be our output. We're going to set our output we're not actually going to set our output because we're in return position. So do we ever need this merge branch? Because the body is always going to be in return position, right? For example, why do we have two nested? Like, why do we have two loops here? It seems a little odd. I know we have an odd time with the unconditional recursion, like this sort of infinite recursion here. Like this function is never going to exit, and so we end up doing odd things with the IR for that. That we need to end up like adding some special cases in for, because right now we're expecting everything to eventually terminate. But yeah, this part seems fine. Grab the parameter. We have our merge. Output is S0. Loop variable is S1. Grab current value. Set is equal to 2 jump. And then we're just never going to get here. But we still generate it. But I don't see why we have two whiles here. That's because we should not be doing this one anymore. Because now we're generating a loop instruction. So we don't need to check for that manually. Okay. Okay. Whew. I was like, oh no, are we processing the loop twice or something? We're not. We're not. Okay. That's great. That is superb. I can jive with that. Let's see what else we got going on. What other issues? Unable to resolve def macro. Okay, did we get errors? Compiler errors? Other errors? All right, let's remove all this. And then let's do this. Suspicious. So I just tried disabling the garbage collector to see if we were getting a premature garbage collection, which is why this is not being able to resolve. But that is not the problem. Instead, the problem is more likely because metadata. We make it pretty far though. We make it down to defen, which is make it down to defen dash. So it's 9% of the way in, but like to make it into macros, like generally once you make it past like the first macro, my experience in like writing a Clojure dialect, once you make it past like the first macro in terms of code generation analysis, then like you can probably make it past the rest of the file. But we're not quite making it past that yet. A lot of these functions look pretty wrong. Like, why is SIGs actually just grabbing nil and returning it? When we look at SIGs is like a really complex function. This is SIGs. SIGs is doing all of this. What? What? Why is this just... But other functions... No, this is also just grabbing nil. Okay. This is an illuminating example as well, where we have equals equals, and we see that there are two arities that are just grabbing nil and returning that. But there's one arity that is actually doing some real shit. And so this makes me think that is it something to do with recursion? So this one, yeah, we have something odd going on. We definitely have something odd going on. I would like to start with a simpler example. Like, look, all of these are just returning nil. Like PRN, pern. All this guy does is call this. Okay, fine. But this is our example. Then we're gonna find out where the fuck everything here is just returning nil. And then we're going to bring all that back. Oops, yeah, I don't want to do that. I want to do this. Why? So what this function should be doing is getting, we should have an instruction to grab the more parameter, and then we should have an instruction for calling PRN. That should be a CPP call. And then a return instruction, at least 3 instructions that do those things, but not grab nil and return nil. I see. Hey, Neko Man. Welcome to the stream. Hope you're doing great. So in the non-recur recursive case, I ended up removing the code that generates the body for that. So now, yeah, now we can grab more and then do a pern with it and return that. Okay, cool. Whew. No sweat. Cool. So now we make it to seek question mark, and then we end up getting a assertion failure. Let's take a look at what's up. Okay, so seek question mark. We have a parameter O. We do a CPP call. I think I could do, if I jump into IR print, I could probably make CPP call look a little better. That'd be a real pain in the ass though, wouldn't it? Hey, Neko Man. Welcome, welcome, welcome to the jank space. The C++ Clojure hacker group. Yeah, fuck that. I'm not gonna change that right now. This is all fine though. Nothing here. We call seekable, that gives us a bool. We convert that into an object ref. We return that. This is all fine. The generated code is also fine. So this failure we're having is on something else. Let's find out what. current block. IR processor 850. What are we doing? Okay, gen arity. And then 276. Right here, current block. And then IR builder 32. Current function. Are we not able to access this at this time? I feel like current block or current function is giving us something invalid right here. We have our builder. Yeah, I don't know if we can actually do this. All right. Nice. So now we are moving on to other errors. I don't yet know what those errors are, or I don't yet understand those errors, but let's take a look. This. Ooh. Wow, these are big functions. Look at this one. 500 values. What is this function? This is deafin. I was telling you, deafin's a fucking big one. Yeah. Like as soon as you know, we're like handling, okay, like one if, one loop, and then, you know, function calls, blah, blah, blah. But when you get into deafin, then you start seeing like, oh, it all comes together. All this stuff is coming together. So many calls. Yeah, we have lots of extra var interns and derefs because we just haven't lifted those yet, which makes this even more. Okay, I don't know where the form. I guess we're gonna have to take a look at this and see where form is in here. Form. So we actually just have this ampersand form. So that means that the code, the failure that we're getting here is probably when trying to, not in this code, but actually in the code that creates this. Okay, what about this other code? This other error. Oftentimes in C++, when you get multiple errors, the second error could actually just be like based on a misunderstanding. Like the compiler trips on the first error and then as a result continues tripping on all subsequent errors. So kind of need to take them with a light step. Yeah, I'm not going to worry about this one right now. But we'll have to see what's going on with the construction of this guy. With form. This is going to be inside of expression stir. I'm going to add a log. Bing bong. So here is, so that's already wrong. This needs to be munged. But is that the only problem? I don't know. Okay, so that fixes that problem, but we're still not seeing where form is used. So what's up with that? What is up with that? I think I'm going to need to go to where we are actually trying to JIT compile all of this C++ and print out Something like this, I think. Now we actually get a more helpful error. So we can see what's going on. We see it's right here actually. So the problem here is that this needs to be munged. We have a parameter called ampersand form for macros. That's an implicit parameter, and that needs to be munged. So that is in parameter. I think we can just munge this right here. And then, yeah, because of this 194, this ends up being a problem with the dynamic call here. So again, yeah, I think that the second problem here is actually just based on the first problem. Okay, let's try that. Nice. So we still had a problem, but now we're moving on. Now we're in subvec land. So if we jump into subvec, what is... So yeah, subvec is referring to v3 here, but we don't actually have... Let me... that'll probably simplify things. Okay, so here's the subvec. V3 is parameter. V3 is dynamic call, depending on the arity that we're in. So here in arity 3, so we have the V3 in arity 2. In arity 3, V3 is a parameter, and we don't end up grabbing it. Why? So we do a from object right here, and then we do our from object here. Huh. I wonder. Oh. So I have a theory that's pretty likely proven based on this. This looks to me like when we do a from object, we're skipping the next instruction, right? So we're not grabbing the parameter, and I think this is even more right because when we do a from object here, we should be doing a C++ call to create v5, and we're also not doing that, and so v5 is not assigned. So that would mean that from object, yeah, because we're doing an extra instruction here and then we're calling into this one, we're actually skipping. Fuck. That's a good one. Easy fix though, one line fix. Off by one. Okay. So what we can do now is give this another go. And symbol V9. So we can see V9 is being set here, but it's trying to be accessed here. Why? By the way, I'm going to jump into here, remove that. We don't need that anymore. Extra printing. V9. V9 is being used here. It's being used here. V9 is only part of this if, though. V9 is a parameter. Fuck. That's a good one. So right now I am doing, apparently, I'm doing some deduping of the parameter instructions, but I'm doing it in a dumb way apparently, because in one branch here, we're referring to the parameter, and then in another branch, we're just trying to reuse that value. But when we get to code gen, because these are in separate branches, they're not in the same lexical scope. Yep, can't do that. Okay, so parameter. What are we doing in here? Parameter just creates a parameter thing. So that must mean that we're doing parameter. That's only if it's recursive, which is not our case. Here's a local reference. Yeah. I think we can't save that as a local. So gensim looks fine. We're doing so we're building the IR for an if, and we're on 561. And we do an unwrap. There are two unwraps on this line. We get here because we know that else is sum, so it's not this one, it's the unwrap here. That's the problem. Okay. So we know we have something that comes right after gensim. Let's take a look at what it was. It would be def macro itself, or one of the things inside of it, which is annoying. There's an if with a let inside. There's an if with a recur. It's probably the if with a let, because from let I don't think we return anything. What we do. Well, we just return the gen of the body here anyway. Could be. Here's a return of an if. So if we're in return position, we still return none. But we would still expect it right here. Yeah, it's probably the if within the if. This right here. Do we not unwrap here, or do we return something here instead of none? Because if we're in a return position, we're not really going to have a value for the else name. Yeah. I think what we do is we do this. Else name, else name. It's only used here. So we do an option. And then we unwrap the option right here. But now we fell in effectively the same spot, because we just finished gensim. Yeah. All right, got more to dig into. And I'm going to call it though. So today we were in the weeds. Today we were in the fucking weeds chat. But this is, we're just trying to get all of these functions in Clojure.core working, compiling properly. And Clojure.core is 7,500 lines, but we're getting there. We're getting there, and we're close. And we've fixed several different issues with the C++ gen, with the IR gen, and we're getting there. But there's more that we just got to smooth out. Once we get clojure.core compiling, then we can throw the test suite, the exhaustive test suite that we have at all of this, and we'll make sure that there are a bunch of bugs that get in the way. This happens every single time I do, because I've done multiple different code gen implementations for jank. Like, you finally get through compiling clojure.core, and that takes a while. And then you can run the test suite, and then you find even more bugs. So we're, I think by the time, based on where we are now, by the time we meet next week for the next stream, we should be done with all of that. So next time, I'm pretty confident we'll just be like, this will probably be merged, and we'll just be tackling other stuff. But yeah, in the next few days probably are just going to be dealing with all of these different cases and trying to make sense of everything. But that's it for now. I've run out of steam. I'm gonna go have a snack and maybe a nap. I hope you guys have a great day. Hope you had a good time, and I will catch you next week.